Hello friends, welcome to my channel. In this video I will cover Vizag Steel Management Trainee 2015 paper with solution. Only technical part I will cover. This is part 7 of this series. A reversible polytropic process is given by this type of question they already asked in ISRO also 2 to 3 times they asked, IAS also around 8 to 9 times they asked. But this is very important. First is P1 V1 to the power, here n is giving, so to the power n equal to P2 V2 to the power n. From here we will get P2 by P1 equal to V1 by V2 all to the power n. P1 V1 by T1 equal to P2 V2 by T2. So these two equations are important. If we solve these two equations, then finally we will get T2 by T1 equal to P2 by P1 whole to the power gamma minus 1 by gamma equal to V1 by V2 whole to the power gamma minus 1 equal to rho 2 by rho 1 whole to the power gamma minus 1. This is very important. In this question they ask the relation between temperature and density. So by T1 equal to or gamma minus 1 or T1 by T2 equal to here they gave n polytropic, so whole to the power n minus 1, gamma replaced with n, polytropic index. So from options we have to check. A is our answer. T1 by T2 equal to rho 1 by rho 2 whole to the power n minus 1. Internal energy of a perfect gas depends on A. Temperature, specific heat and pressure. B. Temperature, specific heat and entropy. C. Temperature and specific heat. D. Temperature only. D is our answer. This one also so many times asked. Internal energy of a perfect gas depends on, they will give the option, temperature only is the answer. This one also so many times asked in lot of examination. GATE also this question was asked. You can check it from my ISRO playlist, ISRO thermodynamics question paper. In that playlist you can get this type of question, different types of question. ISRO around 2 to 3 times they asked this question, and GATE also they asked. Units are also important, A unit, B unit. So in this question the equation P plus A by B square into V minus B equal to RT is known as its van der Waals equation. The degree of freedom of the mechanism shown in the figure we have to calculate. Degree of freedom or mobility M equal to 3 into n minus 1 minus 2 into J1 minus J2 minus Fr. N is number of links, J1 is number of links with number of lower pairs, J2 is number of higher pairs, and Fr is redundant links. So here number of links are this one 1, then 2, 3, 4, n equal to 4, then J1 lower pairs 1, 2, 3, J2 point contact here between 2 and 3 point contact is there, so 1. FR is 1 because 3 we can rotate into independently without affecting the other links, so 1. Put the values m equal to 3 into 4 minus 1 minus 2 into J1 is 3 minus J2 1 minus FR 1. So 3 into 3 9 minus 6 plus 2 8 1. Degree of freedom is 1. The redundant link is important. This one here. This 3 is redundant link because if you rotate link 3, it won't affect the others movement. So this is redundant link. So finally we will get degree of freedom or mobility equal to 1. According to Dunkerless empirical equation, the frequency of the transverse vibration of the system of several loads attached to the same shaft is C is the official answer. Fn equal to Fn1 plus Fn2 plus Fn3 plus up to Fnn or S. Two springs of stiffness 100 Newton per meter each are connected in series and supported a mass of 2 kg. The natural frequency of the system will be how much? So first equivalent stiffness we have to calculate for series is K1 into K2 divided by K1 plus K2, and for parallel connection K equivalent equal to K1 plus K2. In this question already mentioned connected in series, so both are same, K1 and K2. 100 into 100 divided by 100 plus 100 is 200. So we will get 50 Newton per meter. We have to calculate the natural frequency of the system. Unit is hertz. Unit also we have to check whether it is in hertz or radian per second. If it is hertz, then we have to calculate Fn, and if it is for omega n, unit is radian per second. In this question hertz we have to calculate, so Fn equal to omega n by 2 pi or 1 by 2 pi. Omega n is K equivalent by m root r. So 1 by 2 pi root K equivalent is 50 divided by m is 2 kg. So we will get 50 by 2 is 25. 25 root over is 5. 5 by 2 pi, unit is hertz. We will get 2.5 by pi hertz. So from option B is our answer. The natural frequency of the spring mass system shown in figure is closest to, here this is parallel connection, so K equivalent equal to equivalent stiffness equal to K1 plus K2. K1 is 4000 plus 1600, you will get 5600 Newton per meter. Then we have to calculate, here also hertz is the unit, so Fn equal to natural frequency 1 by 2 pi root over of K equivalent by m. So 1 by 2 pi 5600 divided by mass is 1.4, or you can write it as 14 by 10, 14 into, this is 400 into 10. 400 is 20 square, 20 by 2 pi into root 10. You will get 10 root 10 by pi. So approximately we will get 3.1 into 3.1, 10 by pi 3.1, and root 10 also around 3.1. So we will get 9.5 or 6. So approximately A is our answer. Without calculator, you have to go for approximation method. You will get around 10 Hz. In this question, the question is the ratio of the amplitude of the steady state response of forced vibrations to the static deflection under the action of a static force is known as. Here we have to know first transmissibility ratio. TR is force transmitted by force applied, and magnification factor MF equal to amplitude ratio. This is also called as amplitude ratio or dynamic magnifier. Amplitude ratio is amplitude divided by static deflection. X is static deflection and A is the amplitude of the steady state response, and ST is the static deflection under the action of a static force. F is the force, K is the stiffness. So in this question, D is our answer, magnification factor, A by XST. Then damping ratio, this is C by Cc, actual damping by critical damping. Solar cells are made of A. silica, B. steel, C. sulfur, D. antimony. A is the answer. The average load factor of thermal power plants in India is 50 to 60%. C is the answer.